Hey everyone, welcome to The Explainer. Today, we're diving straight into a highly technical problem that I know a lot of you have hit: why local AI coding agents sometimes act like they've got the memory of a goldfish. And more importantly, we're going to look at how a massive open source library officially fixes it. If you're using tools like Codex CLI, you're absolutely going to want to pay close attention to this. Let's start with the frustration we've all felt. Why on earth does a tool like Codex CLI write a brilliant, perfectly formatted unit test on Tuesday, but then spits out a terrible, non-compliant mess on Wednesday? Well, Codex CLI executes tasks by reading instructions from context, but for most teams, that context is completely ad hoc. It might be a rush prompt you typed out, a random line in an agents.md file, or even just some buried comment from 6 months ago. So when you ask the agent to review security or scaffold infrastructure, it literally has no persistent, structured definition of what good actually looks like for your specific workflow. So today, we're going over the roadmap to solve this exact issue. We'll quickly look at the core context problem, explore a huge library of installable skills, see how it natively integrates with Codex CLI, talk about bundles and workflows, go over installation, and finally touch on the real-world limitations. All right, let's get right into the AI context problem, specifically structured rules versus scattered prompts. The whole issue really boils down to this difference. If you rely on scattered, ad hoc prompts, you are practically guaranteeing inconsistency. You might get something reasonable the first time, something slightly off the second time, and by the third, you're rewriting the whole thing yourself. But structured context, that ensures your agent knows the exact operating rules every single time. It's about giving explicit constraints and a persistent memory of your coding standards that travels right alongside your project. Think of it like hiring a new employee. If you bring in a brilliant senior engineer, but don't give them an onboarding manual or access to the company wiki, and instead just periodically hand them a yellow sticky note with a single sentence on it, well, you wouldn't expect them to build cohesive software, right? So why are we expecting our AI agents to pull it off? Which brings us to the solution: a massive library of installable agent skills. Enter the antigravity-awesome-skills repository. This is an immense, searchable catalog, and it's boasting over 1,470 installable agent capabilities. It's MIT licensed, currently sitting at over 39,000 stars on GitHub. And let me be clear, this is not just a list of copy-paste text snippets. It's a full-blown, installable library designed for agents like Codex CLI, Claude Code, Cursor, and Gemini CLI. Now, what's really fascinating here is the format of these capabilities. They're packaged as skill.md playbooks. Basically, a skill.md is a structured markdown file that feeds the AI explicit context, constraints, and output expectations for a specific recurring task. So, instead of an agent guessing how you want a test written, it just reads the skill.md file for write unit tests. It instantly knows your file naming conventions, your assertion style, and your specific coverage targets, all before it generates even a single line of code. To put that into perspective, just look at the highly technical capabilities introduced in the recent version 11.8.0 release. It added a whole suite of algorithmic discipline playbooks. For example, there's a skill called Limily that acts as a gateway discipline. It literally forces your AI agent to explicitly state the big O complexity, name the data structure, and prove termination before it writes a single loop. There's also MathGuard for large input acceleration, and Complexity Cuts, which is a corrective workflow for improving shipped code with poor performance. These aren't just vague suggestions, folks. They are rigorous operational rules. Okay, so how does this actually integrate with Codex CLI? It's all about aligning with the native architecture. The integration is completely seamless. See, Codex CLI natively operates by reading structured context files, like an agents.md file or per directory instructions, before it executes a task. This library mirrors that exact architecture. It just takes those highly refined SKO.md playbooks and slots them right into the directories where Codex CLI is already hardwired to look. There's no complex middleware, no hacky workarounds required. It just perfectly leverages the tool's native context ingestion engine. Now, with over 1,000 skills available, we obviously need a smart way to sort through the noise, which is where bundles and workflows come in. Instead of scrolling through a massive catalog guessing what you need, you can just start with curated bundles. These group skills together perfectly for specific engineering and product roles. Say you grab the back-end engineer bundle. It automatically pulls in playbooks for writing unit tests, reviewing security, and generating infrastructure from spec. It takes this huge decision space of over 1,400 options and narrows it down to a highly targeted, job-specific toolkit. Taking it even a step further, for outcome-driven execution, the library includes workflows. Workflows actually chain these skills together, sequentially. So if you're running a planning workflow, your agent runs the requirements gathering skill first, then moves to task breakdown, and finally hits the spec writing skill. It's basically an ordered execution playbook that seamlessly transforms your raw, ambiguous ideas into build-ready engineering plans, one step at a time. Let's talk about actually taking action with installation and daily usage. We are talking about true installation here, and it is beautifully simple. Since the library is distributed via NPM, a single command, npx antigravity-awesome-skills - codex, drops the library right where your Codex CLI expects it to be. The CLI is interactive, so it'll ask you which bundles or individual skills you want, and then it physically writes those resulting skill.md files straight into your project's expected directories. Once that's done, your daily loop is completely passive. You run the installer just once, the skills land neatly on your file system, and from there you just use Codex CLI like you normally would. The agent automatically consults those structured files at runtime, pulling in all those constraints and formats without you lifting a finger. And as the open source catalog grows, you just rerun the installer to update your capabilities. Super easy. Of course, to keep things grounded, we have to do a quick reality check and cover the limitations and risks. There are a few critical things to keep in mind. First off, this catalog is community maintained. That means the quality of individual skills will vary, so absolutely inspect the files before trusting them in a production workflow. Second, for your continuous integration pipelines, you must manually pin the version using the @ with the version number in your npx command, just to avoid any sudden behavioral changes if the registry updates. Third, these skills lack automated runtime validation. Remember, they are markdown instructions, not executable test suites. And lastly, keep in mind that the installer writes files directly to your shared repo, so you've got to coordinate with your team about which skills are actually getting committed to source control. All right, so now you know exactly why your local AI coding tools keep losing context, and you have the exact blueprint to fix it using the antigravity-awesome-skills repository. With this massive open-source arsenal of structured playbooks right at your fingertips, the only question left is, how are you going to bring persistent algorithmic discipline to your own AI coding workflows tomorrow?